Okay, geometry students, here's a video that's going to hopefully help us out a little bit with IXL standard M.9 within the geometry standard subset. So let's dive in. We're doing some more proofs here. It says Z is the midpoint of VY, segment VY, so there's segment VY, Z is the midpoint, and W is the midpoint of segment VX. Complete the proof that shows that WZ is equal to XY divided by 2. So it's trying to show that WZ, the measure here, is half the measure of XY. Now, in order to answer this question, we probably don't have to read through this entire 12-step proof. In fact, we see the first two steps demonstrate some given statements, and then we have two statements here that show that VZ and VW are half of these two larger segments here because of the definition of midpoint. So if we just take a look here, we've got VZ divided by VY equals 1/2. All right, well, what is that? That's just algebra. Okay, that's just algebra. That's just showing us that if we were to multiply both sides, or better yet, if we were to divide both sides by VY, we would get VZ divided by VY equals 1/2. So what is that showing here? I'll show that to you real quick. Up here, if I know that VZ divided by, equals VY divided by 2, well, if I just divide both sides by VY, well, these would cancel, right? I'm left with a 1/2. And then I've got VZ over VY. That's what they're talking about in step 5 here. So what's the deal? What did we have to do to get that? It's just algebra. Just algebra. So not too bad there. Let's scroll down real quick. Double check, make sure that's correct. Yes, awesome, fantastic. Well, let's dive ahead a little bit. You're going to get similar questions like that in the first 50 points or so of the sub-score. Let's jump up a level. Let's see what we've got. We've got a question where we have to give 2 reasons. Well, here we've got UV is parallel to TW, so UV parallel to TW. I'm going to go ahead and mark that real quick just so that we know that that is indeed the case. So parallel there, parallel there. Okay, those are parallel lines. Prove that VW divided by SW, so VW divided by SW is equal to, all right, equivalent to TU divided by ST. That's that whole side splitter theorem, which we could talk about in more detail later. But we have UV, segment UV parallel to segment TW, that's given. And then we have angle S is congruent to angle S. Well, what's the deal there? That's just reflexive property of congruence, okay? The reflexive property of congruence essentially states that some geometric figure, in this case an angle, is congruent to itself. That's the reflexive property of congruence. All right, so we're going to scroll down up, leave those up there. We see that angle STW is congruent to angle U by the corresponding angles postulate, and therefore we've got angle-angle similarity for triangle STW, so that's triangle STW right here, and then triangle SUV, so we've got SUV, the bigger triangle there. They're similar by angle-angle similarity. And then by definition of similarity, we know that their sides are proportional, so SU divided by ST is equal to SV divided by SW. And then we've got the additive property of length, where we say SU is just ST plus TU. So I'm going to mark that on here. SU, this full length right here, is really just the sum of this length here. There we go. And this length here in green. There we go. So the red is really just the blue plus green. Well, that's the additive property of length. Guess what? They say the same thing in 7. They just transfer to the other side where SV, the long side, is really just SW plus VW. That's additive property of length. So we're just going to go with additive property of length. We're going to scroll down. We're going to get rid of our annotations real quick. Click submit. Wonderful, wonderful, wonderful. And then, of course, they make you fill in maybe 3 reasons. Well, let's skip ahead. Let's skip ahead to another level here. Now we're in the good range. We're up in the B range, and we've got to fill in all these reasons. Oh, my goodness. Look at these reasons we have to fill in. Well, I went ahead and did one and actually got one part wrong, and I want to show you what that looks like. So here it was the problem. The problem was given GH divided by FG, so GH divided by FG is equal to IJ divided by FJ. Excuse me there. Being that those sides are equivalent, proportional, let's put it that way. When you create those fractions, they're proportional. Complete the proof that segment GJ is parallel to HI. Well, we're given all these statements and we've got to come up with reasons, right? Well, basically just walk through the proof. Number one, you can see what I did. You can see where I got one wrong. I was kind of just flying through this and they didn't like my substitution there. We'll see what they thought about that in just a moment. But the first line here, well, that's given. That's given right up there. They told you that right off the bat. And then here we just added, or better yet, they added in that statement 1 to both sides. So what in the world says that we can do that? Well, as long as I add the same thing to both sides, that's just algebra. That's just algebra right there, okay? So that was algebra. Then number 3 says, I kind of interpreted it as substitution because FG divided by FG is 1, FJ divided by FJ is 1. Well, the correct answer according to IXL was actually just algebra. They wanted algebra there. Okay, fine. We'll put algebra there. And then the next part was because we have the same denominators on both sides of the equal sign, we could just combine the numerators. We can do that addition and just place the sum of the two numerators over each denominator. All right. On to step 5. Notice we have FG plus GH equals FH. Well, look at your figure. FG right here, I'm just going to circle it. FG plus GH, well, that's two pieces of one big whole. So FG, this part here, plus this part here, GH, well, that just equals the whole, FH, okay? And that's what they wrote here. That's the additive property of length. And then did the same thing up here. If you have FJ plus JI, when you add those two segments together, you get FI, okay? So that's the additive property of length for step 6. Then in step 7, they say FH divided by FG, so FH divided by FG is equal to the length FI divided by FJ. And you scroll on down here and you see that's just substitution. That's just substitution there. Why? Well, take a look at steps 5 and 6 and step 4. Step 7 is just step 4 written with FH substituted in for this guy, and then Fi substituted in for this guy. So step 7 is really just step 4 with the substitutions from step 5 and 6 done. So step 5 and 6 support what was already stated in step 4 and allows us to make the statement in step 7. So that's just substitution. Substitution right there. And then, of course, angle F equals or is congruent to angle F. That's the reflexive property of congruence. We saw that earlier in this video. And with that stated, with those items stated up above, we've got angle F congruent to angle F. I'm going to scroll up real quick. We got angle F congruent to angle F. And then we have these sides proportional as well as these sides proportional. Well, we've got side angle side. Okay. Right there, we've got side angle side similarity. That's one of our similarity statements, one of our similarity theorems, side angle side. When I got sides proportional to other sides and an angle in between congruent, well, then I know that I have two triangles that are similar. So angle FGH is congruent to angle H. So angle FGH right here is congruent to angle H, all right? Or excuse me, angle FGJ. Sorry about that. I read that wrong. That was angle FGJ. There's angle FGJ. And then there's angle H. Well, those are congruent. Why? Those are corresponding angles. Remember, we know, or better yet, we know that those angles are congruent. not because of corresponding angles, because we haven't proven this to be true yet, but we know they're congruent because we have similar triangles. We know that triangle FGJ is similar to triangle FHI. If they're similar triangles, then we know that all the angles are congruent. Keep in mind that the angles in similar triangles are congruent. And so because these angles are here, and these are corresponding angles, we know that corresponding angles within similar triangles are congruent. So that's just the definition of similarity there. And because of that, we then are able to use the converse of the corresponding angles postulate, which says if I have angles, corresponding angles that are congruent, and I've got an angle there and I've got an angle here, these angles are congruent. Because we know that fact, we now know that GJ is parallel to HI. All right, so that's kind of a longer proof there, but essentially we're building blocks. We're taking what we know and we're constructing a proof to show that two lines are parallel. It takes a little practice, but I think with a little practice you guys will master it pretty quickly. And like I said, if you get it wrong, go down there and read through the proof and then go back and look at your figure, maybe copy a picture of it down on a sheet of paper, and make your own annotations, okay? Or if you have some annotation software on your computer, do it that way. Notice IXL does a pretty good job of explaining the proof as well, and they do a good job color coding too. So just make sure you go back through if you get a problem wrong and you read through that solution. So that's an example. I'm going to run out of time here, but this is an example of when you have to put all the reasons in yourself. And then if you happen to make it to the challenge zone, which if you do, I'm incredibly proud of you, they give you some statements and reasons, and then you have to add in some lines. And so if you need some help with that, send me an email, shoot me a message on Remind, and I'll help you out with that. Good luck, geometry students. I'll send out another video soon for some of the other standards we've been working on.